Hey makers, welcome back to Hub 360 Embedded Sphere, your trusted source for embedded system tutorials and affordable components. Today's project is a motion detection alert system using the SIM800 GSM module and Arduino Nano. This system detects movement using a PIR sensor and instantly sends an SMS alert to your phone, ideal for home or office security. And the best part, all the components we use are available at hub360.com.ng, Nigeria's embedded hardware marketplace. Let's dive in. Here is how it works. A PIR sensor continuously checks for movement. When it detects motion, an LED lights up for visual feedback, and the SIM800 module sends a text message to a predefined number. We power the system using two 18650 LiPo batteries with a buck converter to ensure a stable voltage supply for the SIM800 module. So the components used are our Arduino Nano, SIM800 module, PIR sensor, 18650 LiPo batteries, buck converter.
Which one will be work over the You want to do it again?
No, more like the buck converter side.
Or save again?
Uh-huh.
Save. Okay, remember to tap them.
Or should I?
You know what?
Should I tap them?
You were tapping them earlier, but you need to work over that.
No, this one was already muted, so I don't know.
You have another one.
That was what I want to get.
I think I did. I think
Yeah, you took it.
so I just know it. So I'll put it.
I'm preparing to point.
You know, as far as I took one last.
Yeah, you took one. Okay, the components used are my Arduino Nano, SIM800 GSM module, PIR motion sensor, 18650. Okay, the components used are my Arduino Nano, SIM800 module, PIR motion sensor, 18650 LiPo battery, and a buck converter to step down 7.4 volt to 4.2 volt for the SIM800, a 10 kilo ohm resistor, three 10 kilo ohm resistor, one LED, and some jumper wires. You can grab all this at Hub 360. Reliable, fast, and maker friendly. Okay. So we put our Nano this way, now breadboard. PIR D2 on Arduino. So ground goes to the ground rail on the breadboard. The VCC goes to the plus rail, the positive rail on the red breadboard, and the D out, that's the signal pin, goes to pin 2 on our Nano. So for the SIM800, so we take RX to be D11. Okay, now let's head to the connection. You place your Arduino Nano on the breadboard. You also place your SIM800 module on the breadboard. PIR sensor, this part is our 5 volts, the middle is our digital pin, and the other end is ground. So 5 volts goes to VCC to positive, on the breadboard, and also the signal pin goes to D2, pin D2 on our Nano, and the ground goes to ground on the breadboard. Okay. Okay, so after that we connect uh, RX to with a 10K resistor to our SIM800 module. So we'll connect it this way. So this is our voltage divider for the RX of our SIM800 module. So we'll show you the circuit diagram so you'll be able to connect it. Then after that we can tap so from our SIM800 we have show you the connection where the first one is on GND, the second one is on TX, the third one is RX, and the last one, that's the other one, is RST, and the last one is my VCC. So we need RX now. We take from here and we connect to our RX. Then after that, our TX is to connect to D7, which we tap TX from here. After that, okay, so that's it. So then we come to our battery, where, as you can see, we have soldered our battery in such a way that we solder our battery to our buck converter. So this is a 218650 lipo battery that has that is connected in series. So here it is coming here as a 7.4 volt, but here we stepped it down to 4.2 volt. You can adjust it with your potentiometer to step it down. So this is the 4.2 volts that we will feed to our other, to the left hand side, so as to power the SIM800 module. So you can see our SIM800 is on. Then we use the other end to power our VCC, our Arduino Nano. So how do we do that? We take the V in. We have V in here. So we take our V in, which is the last part, to tap it here to the positive rail of this other end, and we take our ground to the negative end. So you can see it's now well. Then we connect our ground here and connect our VCC here. So you can see our Nano is on. So after that, what do we do now? We connect. Remember, here is plus and minus of our SIM800. So we connect, and the plus is the longer one of the capacitor, whereas the minus is the shorter one. So we connect it to our VCC. This is to smoothen the voltage and ensure that our SIM800 works well. Okay, so lastly we have um our LED. So you can see our LED, and this is the ground and this is the positive. So remember, for our LED, the positive is being connected to D4. So we look for D4. Here is D4. We place it here, and also the other one is connected to ground. So this is it. So we are done with our connections. Then we'll have to package it inside our enclosure. Now let's walk through the Arduino code section by section. Open your IDE and follow along. Include library and define pins. Include software serial.h, SIM800, SIM800 RxTX, and the rest. We start by including software serial so the Arduino can communicate with the SIM800. Next, we define the pins for the SIM800 PIR sensor and LED. After that, we have SIM800 serial GPRS. We initialize a software serial instance named GPRS and a Boolean variable motion sent to avoid sending duplicate SMS message. We go further to where we have void read GPRS response. This function reads and displays the response from the SIM800 module on the serial monitor using a timeout of 3 seconds. Then in our setup, we have serial.begin, GPRS.begin, delay 3000. In setup, we start the serial communication, set pin modes, send the AT command to disable echo, and test the SIM800 module using the helper function test SIM800, which is here, test SIM800 module. So in our loop, we go further to our loop where in the loop we continuously check for motion, turn on the LED when motion is detected, send SMS only once per motion event using motion sent. Okay, and we reset the flag when no motion is detected. Yeah. So also we have test SIM800. So this function runs multiple AT commands to check the SIM card, signal strength, network registration, and battery status, essential for GSM troubleshooting. Then we go further to avoid send AT commands, a simple helper function to send any AT command and read its response used throughout the code. Then we go to void update serial. So what does this function do? This function lets us manually send commands and see SIM800 responses in the serial monitor. Very helpful during setup. Then we have our last function, which is sorry, not the last. We have another function, void send SMS. So this function sends the actual text message using standard GSM AT commands. Replace the number with your recipient phone number. Yeah. So after that, we also have the last one, which is our blink LED. So a small but helpful feedback mechanism. This blinks the LED 3 times after the SMS is sent to show success. Now let's test it live. I'll wave my hand in front of the sensor. LED turns on, and here it is. The SMS just arrived. Alert, motion detected by PIR. Awesome. The system is fully functional. Okay, here are some troubleshooting tips. Make sure your buck converter output exactly 4.2 volts. Use a high capacity battery. SIM800 can draw up to 2 amp burst. Your SIM card must be active with credit and unlock. Keep a capacitor 1000 UF across VCC and GND of SIM800. Check antenna placement for better signal strength. And that's a wrap. You've just built a reliable reward SMS alert system using affordable components from Hop360. Like this video if you learned something, subscribe for more embedded projects, okay? And visit hop360.com.ng to get trusted, tested, and fast ship components for all your projects. Until next time, keep building, keep innovating. This is Hop360 Embedded Sphere, helping you bring your ideas to life.